All right, guys, and welcome back. So in this lesson, we're going to be talking today about how to find an area between curves. So let's start with the basics. So thinking back to what we learned about area last semester in terms of integrals, if we just have some curve f, and we want to find, what is the distance under it from some x value a to some x value b, if we want to find that area right there, that's just the area from a to b of f of x. Now, if you have two curves, so say some f of x and some g of x, and again, you want to find the area between a and b, well, what could you do? Well, I guess what you could do is you could find the area under f, and then just subtract that area under g, which would be this area down in here. So the way you would do that is just say, okay, well, we're going to go from a to b of the f of x, which is the top function, minus the g of x, which is the bottom function. Okay, so that's how you find an area that's between two curves. So just for example, let's say we have to find the area between y equals x minus 2, y equals 4 minus 2x, and the y-axis. Okay, so let's draw this picture out. And that's what I want to encourage you to do on any of these problems, the area or volume. Draw a picture and see what you're working with. So, okay, let's see. Y equals x minus 2. So we go down 2, we have a slope of 1, so it looks like that. And then we have y equals 4 minus 2x. So that has a y-intercept of 4, and then a slope of negative 2, so it'll be something like that. So the area that is between this is 4 minus 2x. The area that is between these two curves is going to be this little triangle right here, because it's also bounded by the y-axis, which is this up and down. Okay, so that's my picture. Once you found the picture and you know what area you're trying to find, the next thing you want to do is find the bounds. One of the bounds in this problem is easy, because the left-hand bound is obviously 0, because that's the left side. If I want to find the other bound, that is this intersection point. So if I want to find this intersection point, what I'm going to do is I'm going to set the equations equal to each other. So to find this point where the two curves intersect, I'm going to set 4 minus 2x equal to x minus 2. And that's going to give me the other bound of this function. Okay, so I'll get 6 equals 3x, so x equals 2 is my other bound. Great. So what that means then is when we're finding this area, once we've found the bound, so we're starting at 0 going over to 2, we're going to find this by just saying, all right, we're going to do the integral from 0 to 2 of the top function minus the bottom function. And because I graphed those each individually, we can see the top function there is 4 minus 2x. So that's 4 minus 2x. And then I'm subtracting the other function, which is x minus 2. Okay, and that's the integral that you would use to go ahead and find this area. Now let's go ahead and work this out then. So that's going to be, let's see, integral 0 to 2. So 4 minus minus 2, so that's going to be 6 minus 3x. All right, so that's not too bad. That's just 6x minus 3x squared over 2. I take that back. It got kind of bad. And then we're going from 0 to 2. So when I plug in the 2, I'm going to get 12 minus 3 times 4, which is 6. And when I plug in the 0, I just get 0 minus 0, so I got an area there of 6. So that's how I can find an area between two curves. I need to find the bounds, which could include the endpoints and then the intersections between the two curves, and then just integrate the top function minus the bottom function. Okay, so now we're going to do some problems with our calculator and with more practice. And if you want to pause the video and try these on your own worksheet and then compare answers, that might be a good idea as well. Okay, so now we're trying to find the two intersections here between 2x and x squared. So again, I've done this, and if we want to find the intersections here, there are two intersections where they both meet, so that's where x squared equals 2x. So that's where x squared minus 2x is equal to 0, so we can factor that out to be x minus 2, so that means x equals 0 and 2. So that means that our bounds are going to be 0 and 2. And again, when we set up these problems, we want to make sure that we're doing like the top function and then minus the bottom function. That gives you the distance between those two. And you're kind of integrating that distance together across the region between the two curves. So in this point, that's 2x minus x squared. So that's just going to be, let's see, x squared minus x cubed divided by 3, going from 0 to 2. So when I plug that in, that is 4 minus 8/3 and minus 0 minus 0. All right, and I mean that's 4/3 if you want, but you can leave it in the original form. Okay, so that again, that tells us this area of this purple area between the curves, that's what we're trying to find. Now let's get to a problem we got to do in our calculator. So we have to find the area between y equals x squared minus 4 and the natural log of x plus 2. So what we're going to do, you guys may not know what these look like, we're going to graph both. Okay, so y equals x squared minus 4 goes down 4 and looks like that. And then as for ln of x plus 2, that makes a shape that looks like that. So the area which we're trying to find is here. And one thing I wanted to point out, some of the area is above the x-axis, some is below. We don't do anything differently. Everything is the same. We're still going to do a top minus bottom. Okay, now, here we have to do a little bit extra work because we don't know what the bounds are. And if we tried to solve this equation to find the bounds, x squared minus 4 equals natural log of x plus 2, well, that looks like a really tricky equation to solve by hand. I don't even know how to do that, and I went to college and grad school. So what we're going to do is use our calculator. So I'm going to graph both of these functions. So I'll graph first off x squared minus 4. And then second off, I'll go ahead and graph the natural log of x plus 2. All right. So then let's go ahead and do that. We'll graph both. Oh, I should just start with a standard zoom window so we don't have anything funky there. All right, so there's the x squared. Here's the natural log. So we see those two intersections right here. So let's go ahead and do second, and we can see the area in between them is what we're trying to find. We'll do second calc intersect to help us find both of these. All right, so we'll do first curve, second curve, guess, and then we'll see which one this gives us. It gives me the one on the left first. So the one on the left is x equals negative 1.685854. So as I go over to one on the right, and I put this as a note right here, but you want to write extra decimal points for your bounds. You know, we know this is AP Calculus, so we want our answers to have 3 decimals so we can get full credit on the AP test. But just so we don't have a rounding error in our answers and they're off by a little bit, we want our bounds to have more than that, probably 5 or 6. So the other bound, we get 2.33826. Okay. So now when I want to go ahead and do this, I'm going to integrate my top minus bottom between those bounds. And we can see kind of based on the picture, you know, that the natural log graph is the one on top, and the negative 1 point is your left bound, the 2.3 is your right bound. So by the way, if you ever get a negative answer on these, you like did it wrong. So just that's an indication something went wrong there. Oftentimes you just switch the top and the bottom one. So we're just going to do negative 1.685854 to 2.33826. Okay. And I'm just going to do my top function, which is the natural log of graph, minus the bottom function. Okay, so go ahead and punch this sucker in on your calculator if you want. Sorry about that. But punch that guy in on your calculator if you want. And we'll go to the main screen, Math 9. We're integrating here natural log of x plus 2, and then we'll close the parentheses. And then make sure you put the whole second one in parentheses, the whole x squared minus 4. I mean, I guess you could distribute the minus, but that's whatever. All right, and we're integrating with respect to x, and my first bound is negative 1.685854, comma, and then the next bound is 2.33826. 33826. Okay. And we'll let our calculator work in that integral for a minute, but that's going to give me the area. And a lot of your homework, the integrals are going to be a little gnarly, and especially if you need to use your calculator to find the bounds, you'll just do these integrals on your calculator as well. So I did this, and I got 12.9438, which is the same answer I got before class 2. That's a good sign. All right, so let's go on and look at 1 or 2 other examples. So here's in this next case, I give you 2 graphs of cosine x, which you can see here, that's in red, and the x cubed graph you can see in blue. And when you graph both of these on your calculators, you're going to recognize, though, that there are actually 2 areas. Because in the one on left, in the left area, we have the blue on top, but in the right area down here, we have the red on top. So if I'm trying to find the total area that is enclosed by these 2 curves, we need to include both of those 2 areas. Okay, so let's go ahead and graph those, and we're going to need to find, it looks like there are 3 intersection points, right? If we look at this, we have 1, 2, 3 different intersection points. So we'll graph both of these. So we have the cosine of x, okay, and then we're going to have the x to the 3rd power minus 9x. All right, so we graph these suckers, and it's going to look kind of like we see with the intersection points. So when we want to find those, again, we'll go to second calc intersect number 5. So I'll just find the one in the middle first, I guess, because I'm right there. So that'll give me x equals negative 0.11058. Again, you want to give extra decimals there. For the one on the right side, we'll do this again. So second calc intersect, first curve, second curve again. And then for the guess, you just like arrow over a little bit towards it. Okay. and then that'll give you that one, which is 2.94396. Okay, and then the other one on the negative side, we'll just do this again. So intersect, first curve, second curve, and then for the guess again, I just arrow over back towards it, and then that'll give me the third one. Okay, now I'm not going to do the integrals on the calculator here, but I do want to show you the setup because I need to actually have two different integrals for the left area and the right area. So I need the left area plus, and then I'm going to have the right area. So that's going to give me the area between both of those curves. So for the left area, again, we see the blue curves on top. So my left area, which goes from negative 3.05388 up to negative 0.11058, then in that case, I see the blue curve on top. So I have x cubed minus 9x minus that cosine of x. And then for the right area, I'll do that in a separate color here, but on the right area, I see the cosine x is on top. The red curve's on top right here. So if the red curve's on top, then I'll subtract the other one. Okay. And for my bounds, I go negative 0.11058 up to the other one, which is 2.94396. And then you do this both in your calculator, add together. You can do that on your own. If you want to plug in your calculator, the answer I got was 40.665. Okay. Anyway, let's go on to another one. Here's an interesting one. What if you want to find the area between ln of x and y equals 9 minus x and the x-axis? So again, let's graph this out and see what this looks like. So we're graphing the natural log of x, and we're graphing 9 minus x. Okay, and this is going to look a little bit different in terms of it, because when we graph this, here's my ln of x graph, and then here's my graph for 9 minus x. But here's the problem. Do you guys recognize there's no top and bottom functions here? But like if we're trying to find this area between them, which is this guy in here, there's no top and bottom. So if you want to draw like a vertical line down, like there's no top and bottom. On the left side, ln x is on top, but on the right side, the 9 minus x is on top. Interesting. Okay, so if there's no top minus bottom in this case, there is another way to do this. We'll talk about in the next video. But the real thing you need to do is split this into two parts. And we're going to split this into two at the intersection. Because what we can see is we have this intersection here. And I'm going to do this in another color. Because if we find the area from this intersect here, and this, by the way, is at 1. You can find that easily. This one's at 9. But if you find this blue area, it goes from 1 to the intersection point. And from there, you're integrating ln of x. So let's go second calc intersect here. So we'll go over a little bit. So we'll go first curve, second curve, guess. And then that gives you the intersection point there, which is at 7.0473. And then 1.9526. So that's like the x, and that's the y value. The x value is the only one we really care about. For now, we'll need the y value tomorrow. Okay, so what that means is that if I want to find this blue area, the blue area here is saying I'm going from 1 to 7.0473, and in that region, I'm integrating the natural log of x. So there's no top minus bottom. I'm just finding the area under the ln of x curve. And now, in a different color, let's do it in red. If I want to find this area here under 9 minus x, again, there's no top minus bottom, and the ln of x doesn't even affect this area. So for that area, I'm just going 7.0473 up to the intersection at 9 of 9 minus x. And that'll give me the red area that I need to add those two together. Okay, so that's area between two curves. Thank you guys for watching, and I'll see you guys in the next video to find out the y's.